Hi students, I think it is timely for us to introduce to you guys an extension on cyclohexene here, which involve a little bit of conformational analysis as well. Okay, so this particular extension is related to question 2a in your IR MS tutorial. Okay, so if you look at the question and you look at the teaching solutions we have given you, you will probably be looking at something like this. Okay, I will not go into details like why is it that you get a cyclic bromonium, etc. But you probably want to be aware of this particular limitation when we said that the chloride actually approach from the two carbon with near equal probability. You might realize that this is or an inherent assumption is being made here, that is the cyclohexene exists as a flat molecule. We know that this is not the reality, okay, because you might be aware of if I draw a cyclohexane over here, it is not a flat molecule. Okay, it exists as a chair conformation. Most of the time, you guys will draw a cyclohexene with just a chair and then a double bond like this. Well, this is actually not correct, because if you draw it like this, you realize that both the H are actually kind of pointing in this kind of direction, which makes the whole system looks a little bit weird. Okay, so if we want to really delve into it, then maybe I will just do a little bit of modeling for you. So let me just copy out cyclohexene here. Okay, so this is cyclohexene. I will paste this into the Chem 3D. Okay, so this is the modeling we are looking at. This is the model we are looking at, and let me do a little bit of minimization of energy. Okay, so that you get at least the most stable local minimum conformation. Okay, if you scrutinize the structure, right, let me just rotate a little bit more. You realize that this is the CC double bond, and then the other four carbons are the sp3 hybridized carbon. Okay, so let me just do a quick rotation like this, right? You notice that this and this carbon, right, they are actually located along the same planes. Okay, so let me just do a very slow rotation for you to see. Okay, so if I put this at this particular level, you see that this carbon and the one at the back same plane. Okay, let me do a rotation again. This carbon and the one at the back in the same plane, and then this carbon at the back in the same plane. So I hope this actually convinces you that in cyclohexene, right, four of the carbon atoms are in the same plane, and the other two, one of them is pointing up and the other one is pointing down. Okay, and then these two H's is projecting out towards you. How do we actually represent it flat on paper? Okay, so basically all I need to do is just to draw a double bond, okay, like this. Okay, and then the one that is projecting behind, I just draw it up, and then the one below, I just draw it down, and then I just connect the two carbon like this. Okay, so this is the way we should draw it. But you notice that this looks a bit weird because it seems that the CH2 is just right in front of us, which is actually okay. But normally for teaching purposes, we want to put the alkene right in front of us. Okay, so this is the conformation that one of the conformation we're looking at. There isn't a need for you to actually draw out the H's, but if you really want to draw out the H's, you may draw out. So the H's will look like this, projecting out towards you, and then the other one will be projecting out towards you as well. And then if you wish to, you can just put in the H's. Okay, but maybe let me just remind you that this is really not crucial for you, okay, to actually draw out the H's lah, because sometimes it will cloud our observation. Okay, but of course, if the student wish to, then why not? Because sometimes it might help you to understand some concepts. Okay, now this is one of the stable conformation we're looking at. There is actually another stable conformation that if you wish to, you could actually draw it out. So it's actually, instead of the carbon behind the first double bond pointing up, it can actually point down as well. Okay, so and then the other one will be pointing up, and then you connect the two, and then again, I need to show the correct perspective. So this is what I'll get. Okay, so this is another stable conformation. So basically, it will do a ring flip over here and here. So you push this up, and you push this down, and then you get this. Okay, but of course, the purpose of me showing you this is not to show you the conformation of cyclohexene. And maybe let us reiterate that it is not a requirement for you guys for H3 curriculum to show the proper conformation of cyclohexene. Okay, I hope this will relieve some stress from you lah. But as I've mentioned, we want to provide you with some extension to the curriculum you are learning. So that's why the purpose of this particular video. Okay, so with this in mind, let us do a little bit of analysis on the electrophilic addition again. Okay, so let me just remove the H's because it will cloud some of our observations. Okay, now we'll use this particular cyclohexene. Okay, you may use this as well, yeah, but take note that later on at the end of the video, right, we would really love you all to practice with both conformation, allowing the bromine to approach from the top and bottom plane. Okay, it is only when you practice drawing that you will be comfortable in showcasing your answer. Okay, so again, this is for interest, it's not for assessment purposes. Okay, of course, assessment purposes, if we really want you all to do it, we will give you a context for you to look at. Okay, it will not be something that we test you out of the blue. Okay, so right, so I will not be drawing the electrophilic addition, okay, mechanism in its totality lah. Okay, I will just showcasing bits and pieces of it. Okay, so you get the BR here. Okay, so so in my example here, I'm showing the top face of the bromine being added. Okay, so just the top face being added. Okay, now I'm just going to copy the chloride over. Okay, so to make my drawing a little bit faster. Okay, so I'm just going to copy the chloride over here. Okay, and I'm just going to change it to blue. Okay, so now you know that the chloride can approach from both carbon. Okay, so if it approaches from here and the bond breaks like this. Okay, so I'm just going to put it in blue. The bonds break like this. Okay, now I just want you to maybe pause for a little while to think about what do you think the transition state will look like. Okay, just pause for a little while. What do you think the transition state will look like? Okay, and I'm just going to draw another one below. Okay, again, same thing, but for this time, the chloride is approaching from the other side. Okay, oops, yeah, I need to do the rotation a little bit properly. Okay, right, yeah, so now the chloride is approaching from here, and then I'm just going to simplify things a little bit, I'm just going to color code in red. Okay, and then I'm just going to show the other arrow in red as well. Okay, I want you guys to think about this. Okay, how will the transition state look like? Let me just emphasize the term again. We are looking at the transition state. Okay, so just 2 or 3 minutes, try to envision it, and then we'll continue later on.